Good morning, dear students. My name is Farhan Mazhar, and the subject we are studying is Physics 5054. This is Cambridge O Levels Physics. Today, we are working on the revision checklist, and there are 6 topics in the syllabus of the Physics 5054. And in this video, we are going to work on the revision checklist for the topic number 5, which is nuclear physics. So we will have a table in which we will have the main topics, the contents which you need to know. So let's start that thing. Okay. So today we are working on the topic number 5, which is nuclear physics. So you in front of you, you can see there is a table, and this table has 4 columns, and what these columns represent. So in this part, we have a guide we in which we are providing some revision checklists. These include information from the syllabus that you should revise. They do not contain all the detailed knowledge you need to know, just an overview. For example, for more detail, see the syllabus and talk to your teacher. The table headings are explained as. So this first heading, which is topic, these are the topics you will study. And the second column, which is you should be able to, these here we have the content in the syllabus you need to cover. And then we have these check boxes, and there we have 3 colors. Here you can use the tick boxes to show when you have revised an item and have confident you feel and how confident you feel about it. Here R, which is red, means you are really unsure and lack confidence. You might want to focus your revision here and possibly talk to your teacher for help. Here A means the amber means you are reasonably confident but need some extra practice. Here green G, which represents green, means you are very confident. As your revision progresses, you can concentrate on the red and amber items in order to turn them into green items. You might find it helpful to highlight each topic in red, orange, or green to help you prioritize. The last column, which is about the comments, you can add further information of your own, add learning aids such as rhymes, poems, or wordplay. Pinpoint areas of difficulty you need to check further with your teacher or textbooks. Include reference to a useful resource. So the table cannot contain absolutely everything you need to know, but it does use examples wherever it can. So we are working on the topic number 5, which is the nuclear physics. And the first topic is the nuclear model of an atom, the atom. You should be able to describe the structure of the atom in terms of a positively charged nucleus and negatively charged electrons in orbit around the nucleus. Describe how the alpha particles scattering experiment provides evidence for a very small nucleus surrounded by mostly empty space, a nucleus containing most of the mass of the atom, a nucleus that is positively charged. We famous this experiment is famous, and we also call it Geiger and Marchson experiment. The second topic is the nucleus. Describe the composition of the nucleus in terms of protons and neutrons. Describe how atoms form positive ions by losing electrons or negative ions by gaining electrons. Define the term a proton number, which is atomic number, Z, and the nucleon number, which we call the mass number, A, it is represented with the capital A, and be able to calculate the number of neutrons in a nucleus. Number of neutrons are the proton number minus the nucleon number minus the proton number. And explain the term nuclide and use the nuclide notation XZA. Explain what is meant by isotope and state that an element may have more than one isotope. The definition of the isotope frequently come in exams. Radioactivity, detection of the radioactivity, describe the detection of alpha particles using a cloud chamber or spark counter, and the detection of beta particles. Beta particles will be taken to the reference to beta negative, and gamma radiation. This is the symbol for gamma radiation by using a Geiger-Müller tube and counter. Use count rate measured in counts per second or counts per minute. Know what is meant by background radiation. This definition comes frequently in the paper. Know the sources that make a significant contribution to background radiation, including radon gas in the air, rocks and buildings, food and drink, cosmic rays. Use measurements of background radiations to determine a corrected count rate. The three types of emission. Describe the emission of radiation from a nucleus as spontaneous and random in direction. Describe alpha particles as 2 proton and 2 neutron, which is like helium nuclei. Beta particles as high-speed electrons from inside the nucleus, and gamma radiation as high frequency electromagnetic waves. State of alpha particles, beta particles, and gamma radiation, their relative ionizing effect, their relative penetrating powers. Describe the deflection of alpha particles, beta particles, and gamma radiation in electric fields and magnetic fields. Radioactive decay. Know that radioactive decay is a change in an unstable nucleus that can result in the emission of alpha particles or beta particles and or gamma radiation, and know that these changes are spontaneous and random. Use decay equation using nuclide notation to show the emission of alpha particle, beta particles, and gamma radiation. Fission and fusion. Describe the process of fusion as the formation of a larger nucleus by combining two smaller nuclei with the release of energy, and recognize fusion as the energy source for stars. Describe the process of fission with a nucleus such as uranium-235 absorbs a neutron and produces daughter nuclei and 2 or more neutrons with the release of energy. Explain how the neutrons produced in fission create a chain reaction, and that this is controlled in a nuclear reactor, including the action of coolant, moderators, and control rods. Half-life. Define the half-life of a particular isotope as the time taken for half the nuclei of that isotope in any sample to decay. Recall and use this definition in calculations which may involve information in tables or decay curves. Describe the dating of objects by the use of carbon-14. Explain how the type of radiation emitted and the half-life of the isotope determine which isotope is used for application, including household fire smoke alarms, irradiating food to kill bacteria, sterilization of equipment using gamma rays, measuring and controlling thickness of material with the choice of radiation used linked to penetration and absorption, diagnosis and treatment of cancer using gamma rays. Safety precautions state the effect of ionizing radiation on living things, including cell death, mutation, and cancer. Explain how radioactive materials are moved, used, and stored in a safe way, which refers to reducing exposure time, increasing distance between source and living tissue, use of shielding to absorb radiation. So, my dear students, these are the main topics, content of the syllabus. You should be able to answer. And this video, we were talking about the topic number 5, which is from the nuclear physics. So I hope this video will help you. I will upload this file in the description of this video, and you can download this file. Its name is the Learner Guide, which is issued by the Cambridge, and this is for the examination which is starting from 2023. So I hope this will help you, and it will improve the quality, the effectiveness of your revision. So thank you very much, everyone. Have a good day, and God bless you all.